In this video, I will show you how to identify turning points and relative extrema of points on a polynomial function. A turning point of a function is a point where a graph changes from increasing to decreasing, or vice versa. These points are relative extrema as they are the highest or lowest points of the points around them. Some books also refer to those as local extrema. I have a polynomial, p of x equals x to the 7 minus 6x to the 5 plus 9x cubed minus 4x. We know that the degree of the polynomial is 7, right? It's the largest exponent. But there are 6 turning points. Now, I know that by looking at the graph. I have the graph of this function shown on this page. So we remember that the end behavior tells us because it has a positive leading coefficient and an odd degree, it goes down to the left and up to the right. And as we graph this, it goes up to some maximum point and then down and back up and then back down and then back up and then back down and then back up. So how many times did the graph turn? It turned at 1, 2, 3, 4, 5, 6 times. 3 of the turning points are relative maximums or relative maxima, since they are the highest points of the graph, or we sometimes call those the peaks of the graph. The remaining 3 are relative minima, since they are the valleys of the graph. To obtain the actual coordinates of those turning points, I had to use a calculator, and I will show you how to do that. But the key is to remember this, that a polynomial function of degree n has at most n minus 1 turning points. Now, finding most turning points algebraically requires us to use calculus. We don't have those skills yet, but we can use a graphing calculator. If you have a TI-83 or a TI-84, you will want to learn how to use that. Otherwise, you can download the Wabbit Emu app that I've talked about before. You can download that app onto your phone for free, and you can use the same functionality that the TI-83 or 84 has on your phone. And there's also a great graphing calculator tool online called desmos.com. But in any case, for this part of the course, you will need some graphing utility to help you find the coordinates of these maximum or minimum points. Before I show you the calculator, I have 2 pictures of polynomial functions on this screen, and I want us just to be thinking about what would we know about the polynomial function just based on the graph. And so the first polynomial function is down at the left, and it goes up to a point, comes back down, and then up. So based on that end behavior first, if it goes down to the left and up to the right, remember that kind of resembles a graph of x cubed, we know that there must be a odd degree, and we also know that there must be a positive leading coefficient. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . we know that there are 1, 2, 3 zeros. So that tells us that the degree has to be something like 3, 5, or 7, right? 3 is a minimum it can be. And we also know that those zeros, because it crosses the graph, crosses the axis at each of those zeros, that each multiplicity is an odd value. How many turning points are there? There are 1, 2 turning points. So that again tells us that the degree has to at least be 3. There is a relative max and a relative min. The other polynomial function almost looks like a W, right? It's up at the left and up at the right. So we know when it does equal things, it has to be an even degree. And because they're both up, it's got to be a positive leading coefficient. There are 1, 2, 3, 4 zeros, which tells us that the degree has to be 4, 6, 8, and so on, right? At least 4. It has to be an even number. And we know that each multiplicity of those zeros is odd because the graph crosses at each one of those zeros. And there are how many turning points? So we went down, came up, and then went down, and then came back up. So there were 3 turning points. Again, confirming the fact that there had to be at least a degree of 4. And so there is a relative min, another relative min, and then a relative max. Okay, so just be thinking about all those things that we've kind of learned, right? Because again, I keep saying this, we're building to being able to graph a function on our own, but it's really important for you to see how all of these things relate to each other. Okay, so in the next screen, I have an example of a polynomial function, that one that I mentioned earlier, the x to the 7 minus 6x to the 5 plus 9x cubed minus 4x. And what I have here are screenshots from the graphing calculator to show you how to identify the coordinates of the maximum points. The minimum would be very similar to this. We just use a different function. But you will enter the equation on your calculator, and I will actually give you a calculator video that will show you this. You'll enter the polynomial function into the equation editor, and then there is a calculate menu that you want to access. And depending on whether you're going to find the maximum or minimum, you're going to choose one of these 2 options, either number 3 or number 4. And that will then take you to the graph of that function. And so if you want to find, I chose here the maximum. If we're trying to find the coordinates of this maximum point, the calculator will ask you for a left bound and a right bound and a guess. The left bound means that I need to be somewhere on the left side of that maximum point. So if you envision a vertical line down through this maximum point, to do a left bound, I need to be somewhere on the graph to the left of that point. And it doesn't really matter where you are. Try to stay pretty close to it. But you're just going to move your cursor until you get to the left side. And then you'll press enter. So move your cursor to the left side and then press enter. And then it will ask you for a right bound. And you'll also notice that it will place a little marker when you say the left bound and you've pressed enter. Well, for the right bound, again, I need you to think about a vertical line through that point and go somewhere to the right of it, and then press enter. And then you'll notice that it puts a little mark, so where you've placed your left bound and right bound, and then it asks you to guess. So for you to guess, you're going to move the cursor somewhere between those two marks, and then you're going to press enter. And down at the bottom of the screen, it's going to display the coordinates of that particular point. And then you'll just continue to repeat this for each of those maximum or minimum points that you have. You just really have to know, am I going to use a maximum or minimum? So like if I wanted to find the coordinates of this other turning point, the next one, notice that that's a minimum point, right? That's in a valley. So I'd have to use the minimum function to do that one. The next one is a maximum because it's like the peak of the mountain. And then going down, I'd find the minimum, which is in a valley, so the minimum function, and then max, and then min. So you just have to know which of those two functions are you going to choose, max or min. And then the process is the same. I want to be on the left side of it for my left bound, the right side of it for my right bound. Move in between the markers for your guess and press enter. So I have one here for you, and I'll have to stop this video and make another video for the graphing calculator to show you, but why don't you start on this one? It's negative 2x cubed minus 10x squared plus 6x minus 9. So what I want you to do is to graph that function and to find any relative extrema. That is, any maximum or minimum points in a little area.